Remember, slope is going to be the one that is connected as a coefficient, so -4. Y-intercept is the value that is your constant, whether is added or subtracted. If it's added, it's positive. If it's subtracted, it's negative. So we get a +7 for the y-intercept. For problem number 2, identifying the types of slope. What is the slope or the type of slope for each of the lines? This is a positive slope. This one's going to be an undefined slope. Vertical lines are undefined. And then horizontal lines are 0 slope. So vertical is undefined. The flat line is 0 slope, 0 fun. Okay? So positive, undefined, 0. Number 3, finding the slope by given points. Remember, the point or the formula for slope is y2 minus y1 over x2 minus x1. So you're taking the difference of your y, so -2 minus the 18, and then the difference of your x, 6 minus -4. 6 minus -4. When you type that into your calculator as is, if you type it exactly as that, as a fraction, so literally hit your fraction button, and then just type in 2 minus 18 over 6 minus -4, and hit enter. Oof, I typed something wrong, didn't I? Oh, -2, my bad. -2 minus 18 over 6 minus -4, and it'll come out to -2. So just type it exactly as it should be in the fraction form, hit enter, and it'll spit out to you what your fraction or whatever your slope is going to be. For problem number 4, find the slope of a table. You have to find the change of the y over the change of the x. So the change of the y occurring here, remember, as your negative value, if your negative number looks like it's increasing, it's actually decreasing. Okay, the larger the base is for a negative, the smaller the negative value is actually worth. So -2 to -6 is a decrease of 4, not an increase. -6 to -10 is a decrease of 4. From -10 to -14, that is also a decrease of 4. For your x's, you're consistently increasing by a 1. So you have -4 over 1. -4 over 1 is just -4. For problem number 5, finding the y-intercept, it's just the point that you cross over the y-axis, -3. Okay. Number 6, initial values. Remember, if you see the term initial value, initial fee, initial membership, that is the y-intercept. It's a starting value. So initial value is another way of saying y-intercept. So our y-intercept here is $30. That's the initial value of signing up for a membership to the gym. Then you also pay $15 per month. When you see that word per, that means coefficient. Coefficient is your slope, and apparently I forgot the E on the end. Okay, so the coefficient is how you create your slope. So $15 would be the slope. So our equation in slope-intercept form is y equals 15x plus 30. For problem number 7, graphing. Remember, when you graph your y-intercept first. Our y-intercept is at -3. So we're going to go onto the graph and plot the point -3. Then we're going to use our slope as directions. Since our slope is negative, that means it could be a -2 over 5, which means you'd go down 2 to the right 5. Or you could do +2 over -5, meaning you go up 2 and then to the left 5. You use those as coordinates to plot your next points. So going, up 2, left 5, up 2, left 5, or down 2, right 5, down 2, right 5, and it creates a negative looking graph. If you know your slope is negative, it must be in the negative direction. Okay? Number 8, writing the equation. So given a graphed line, write the equation. The point for the y-intercept crosses over at -3, so I know it's going to be a -3. And then I just have to identify the next set of points. So if I find a next set of points and find the slope that goes to it, up 1 to the right 2, up 1, right 2, up 1, right 2. So if I'm going up and right, obviously this is a positive graph. So 1 over 2. So 1/2 x minus 3. Okay, problem number 9. For problem number 9, we are finding the equation of the table. So find the slope first. Our y value is decreasing by 1, while our x value is increasing by 2. So it's a -1 over 2. And then our y-intercept happens to be given to us because it's when x is equal to 0 And we have that point on our table. So our y-intercept is at positive 1. So we get y is equal to negative 1/2 x plus 1. Any questions so far from that first page? Going once, going twice. Good. Number 10. Let's take a look at problem 10. Which equation represents a linear equation? Write this down, please. If it is linear, you cannot have an exponent or a root for your variable. You are not allowed to have exponents on your variable. You're not allowed to have your variable inside of a root. Those are big no-nos. That's why we were able to get rid of, line A, or not line, but function A, because x cubed. And we were able to get rid of function C because the square root of 4x, which would technically be 2 square root of x. You cannot have an exponent for your variable. You cannot have your variable inside of a root. You also are not allowed to have your variable as the denominator of a fraction. If your fraction has a variable in the denominator, then that is not a linear function. Remember, the only ways that we have displayed linear functions have been ones that are written in y equals mx plus b, so stick with that. Okay? Let's take a look at problem number 11. Problem number 11, you're identifying if it's linear or nonlinear or not linear. Remember, if it's linear, it has to have a slope or a constant rate of change. So only tables A and B, the first two tables, are considered to be linear. The first one has an increase of 3 over an increase of 1. The second table has a decrease of 1 over an increase of 2. The third table is not linear because even though your x's are consistently increasing by 1, your y's have a different or a variability to it. You're decreasing by 3, decreasing by 1, then increasing by 3, increasing by 1, then increasing by 3. So there's no consistency for your y when there is consistency for your x. So this is not linear. Number 12, given the function y is equal to 6.5x, what's the slope? The slope is 6.5. What's the y-intercept? Since there isn't anything added or subtracted, we know that the y-intercept is 0, because 0 does not have to be written there as a y-intercept. You don't have to write plus 0 or minus 0. Girls? For problem number 13, we want to know what is the rate of travel. So remember, when we're talking about a rate, we're talking about per 1. So if we find the slope, our slope is increasing. So it's a rise of 92 over a run of 2. And 92 over 2 gives us 46. Sorry, sloppy handwriting. Gives us 46 miles per hour. So there is our rate. For number 14, given the following function, we want to indicate what the slope represents based off of the scenario given to us. He states that he's got 42 cards at home. That's an initial value. That's your y-intercept. So hence the reason they have plus 42. Then he's going to buy 5 cards each week with his allowance. So that's your slope. 5 cards that he's going to purchase each week. Number 15, I know that I have the question here, but the graph is on the back. So 15 is saying triangle ABC and CDE are similar triangles graphed on the coordinate plane. We're going to write a statement about their slopes. So if they are similar triangles, then that means that their slopes are equal. If they are similar triangles, their slopes must be equal. So if we take a look at AC, line segment AC, it has a slope of negative 3 over 2. I know it's hard to read. Negative 3 over 2. And then line segment CE has a slope of negative 6 over 4, which simplifies to negative 3 over 2. So the slopes are equal to each other when they are similar triangles. So similar triangles equal slopes. Number 16. Remember I told you guys that this was supposed to say minutes, not the hours. I informed you. I forgot to inform my other class. But for here, the graph is resembling that at 2 minutes, it's 6 gallons that are used for the bathtub. So the graph is representing how much gallons is used per minute for the bathtub. So over a period of 2 minutes, they use 6 gallons. The hose is used with this equation, y is equal to 2x plus 6. So where x represents the minutes, we need to plug 2 minutes in for x. So we do 2 times 2 plus 6. 2 times 2 gives us 4. 4 plus 6 gives us 10 gallons. So after 2 minutes of using the hose, 10 gallons of water has been dispersed. So the hose is actually using more gallons after 2 minutes than the bathtubs. Okay? Number 17, identifying if it's linear or not linear. Remember, what was the key word in linear? Linear means what? No, it doesn't mean straight. It's a line. Lines, by definition, are straight, right? I mean, hopefully. They're supposed to be straight if it's a line. So if you see the word linear, you should be looking for a line. So linear, nonlinear, nonlinear, linear. Yes, no, no, yes. All right. Number 18, identify as a function versus not a function with all the functions on the other page. We're identifying these as functions or not functions. Remember, if it's a function, then the x's with these little circular diagrams should only have a single branch extending from them. So each of these only has a single branch extending from it, makes it a function. However, this one is not a function because the 5 has 2 branches coming off of it. The fact that it has 2 branches extending off of it makes it not a function. Okay, for the tables, if a table is a function, then the input or the x should not repeat. If you see any repeats, then it is not a function. I'll write them longer. For the second table, there are no repeats for my input, so it is a function. For my last table, all the way to the right, the 4 happens to repeat, so that is not a function. Okay, now for graphs. Graphs dictating whether it's a function or not has to pass a vertical line test. You need to know that terminology. Vertical line test means that when you draw a vertical line anywhere on the graph, it should only pass through the relation at one point. So if I pass through it here, and then here, and then here, and here on separate vertical lines, that's okay. It's a function. But here, when I draw one vertical line, I'm passing through it at 2 different points. That is not a function. For the graph of the circle, when I draw a vertical line, I pass through it at 2 points. That is not a function. On the last one, when I graph a vertical line, I only pass through it at 1 single point for each vertical line. So that is a function. Then when you're given actual data, when you're given actual data set or order pairs, looking here, none of my x values or my domain, none of those repeat. The range repeats though. Is that okay? Can the range repeat? Yeah, the range is allowed to repeat. It's the domain, the x, that's not allowed to repeat. Since it does not repeat, we got a 1, a 2, a 3, and an 8. Does not repeat, it is a function. For the second one though, this is not a function because the domain of 2 repeats. So that is not a function. Again, you're going to have a question that's got like 8 different relations and you have to indicate function or not. So it's a drag and drop kind of thing. All right, number 19, identify the domain and the range of this relation. So remember, the domain is the x values. So the domain is going to be a 4, a 6, a 10, and it happens to have 2 12s, but I only have to write the 12 one time. But because of the fact that it has 2 12s, does that make it a function or not? It's not a function. The range is a 7, an 8, a 9, a 13, and an 18. So there's the domain, there's the range. It's not a function because of the fact that the 12 repeats. Number 20, list all possible values that could make this not a function. So if I do not want it to be a function, then I can make this missing value a 4 or a 6 or a 10. Either one of those would make this not a function anymore for this value right here. So the x could equal a 4, a 6, or a 10. All right. Number 21. Given the function f of x is equal to 2/3 x minus 8, what is the range if the domain is -9, 0, and 5? So if I plug in -9, I'm going to get -14 because 2/3 times -9 minus 8 will give me -14. If I plug in 0, I'm going to get -8. If I plug in 5, I'm going to get -14 over 3, or -4 and 2/3, or -4.6 repeated. Okay. Another word for rate of change is slope. Another word for initial value is y-intercept. Number 24, list the 3 ways to identify that a relation is a function. Number 1, the domain doesn't repeat. That's important. The domain does not repeat. Number 2, each domain belongs to exactly one range. The domain belongs to exactly one range. That's important. And then number 3, if it's graphed, it has to pass the vertical line test. Those are the 3 indicators that you should be looking for on your test, hint, hint, that would state that it is a function or not. If it is a function, there's no repeat of the domain. The domain belongs to exactly one range. When graphed, it's going to pass the vertical line test. Number 25, looking at this graph, we want to know which story is going to match it. If we look at the graph, we've got a horizontal line. That means it's a steady rate, a steady speed is occurring. Then we're going to decrease in speed until we stop. Then we're going to increase up until we get to a slower pace. Okay, that would be A. Swimmer starts at a steady pace, slows to a stop, starts back up, but starts at a slower pace than before. Okay. Number 26, substituting x in for the x value, so -4 times -5 plus 3 gives you a positive 23. Number 27 is going to be on the back. Given the domain and range of the relation, tell whether the relation is a function. So, looking here, the domain is going to be 0, -2, and 3. We don't have to state the 0 twice. And because of the fact that it repeats, it's not a function. Not a function because of the fact that it is repeating. The domain is 0, -2, 3. The range is -5, -1, 3, and 5. So remember, domain is x, range is y. You need to write that down. Domain is your x, the range is your y. Okay? Problem number 28. Which value would make x not a function? So it could either be a 7. Well, we don't have a 7 here. It could be a -2. I don't have a -2 listed. A 4. I have a 4 here. So if I put a 4 for my x, that would make it not a function. Number 29. What relation is a function? You're looking for the table that does not have any repeats for your x. The only one that has no repeats for the x is graph A, or table A. All right, flip it to the back. Number 30, Arnold earns $60 after 10 hours of work, and he gets a daily bonus of $25. What's the function that describes his rate of pay? that would be 6x plus 25, because I know a lot of people chose 60x plus 25, but 60 is how much he gets after 10 hours, not after 1 hour. So you'd have to do 60 divided by 10 to get $6 per 1 hour. So $6 per hour, so 6x, plus that initial rate of $25 for his bonus. Okay? 31, which relationship is going to show that the domain is assigned to exactly one range? So basically, which one's a function? That would be graph B. Number 32. Plug in these values of domain and find out the range, and then graph the range. So if we plug it in, please note that this says negative x plus 2. That's also another way of saying the opposite of x plus 2. So if I do opposite of negative 2 plus 2 will come out to a positive 4. The opposite of 0 plus 2 is going to come out to a positive 2. And the opposite of 5, which is negative 5, plus 2 comes out to negative 3. So we get 4, 2, and negative 3, and then we graph it, which would be answer choice B. Okay, flipping. Number 33. Tyler selected answer choice B to represent the scenario of a woman who climbs up a hill at a steady pace and then starts to run down one side. So if you're climbing up the hill at a steady pace, is your speed going to be increasing, decreasing, or solid? Solid, like a flat line, right? So he says that she's going to increase her speed as she's going up the hill. I don't know about you, but when I'm going up the hill, I don't walk faster. Okay? And then he says that, hey, once she gets to the top of the hill, when she goes downhill, her speed is going to get smaller. Again, if you're going down the hill, you're probably going at a faster pace or falling. One or the other. A is going to be the correct answer choice. You're having a steady rate going up the hill, and then as you get to a point where you're at the top, your speed is then going to increase as you go down the other side, okay? So you have to note that this is talking about speed. This would be a good representation of height of the hill. So as you are walking, as time elapses and you're going up the height of the hill, you're walking up the hill, then you walk down the hill, that would be a good representation of your height. But this is talking about speed. So you have to make sure you're aware of what the axes are labeled. Okay? For number 34, this is just the slope formula. So y2, which is 279.93, minus y1, which is at 79.98, right here, minus x2 minus x1. So on the bottom, x2 minus x1, so 7 minus 2. When you simplify, it comes out to 39.99. So you're just using that formula right here. Y2 minus y1 over x2 minus x1. And we're almost done. Okay, last one. No, second to last one. Here, we're saying that the input value is multiplied by 2 and then decreased by 6. Multiplied by 2 is a coefficient. Decreased by 6 means you're subtracting 6. Then we're going to plug in the range of negative 3. That negative sign's over here, my bad. Negative 3, 0, and 3. So when we plug in negative 3, it's 2 times negative 3 is negative 6. Negative 6 minus 6 is negative 12. When we plug in 0, 2 times 0 is 0, minus 6 is negative 6. And we plug in a positive 3. 2 times positive 3 is 6, and 6 minus 6 is 0. Now the last question. Movie rental store charges $25 a month for a membership, and then $1.50 per movie that you are renting. So you have an initial rate of $25, and then $1.50 for every movie that you rent. So that equation is y is equal to 1.5 or 1.50x plus 25. If you rent 6 movies, you're going to do $1.50 times 6, then plus 25, you get 34. Your initial value, again, is your y-intercept. So you would plot that as a point, 0, 25. That's what they mean by identifying it as an ordered pair. That is the cost of the monthly membership. And then part D, what is the slope? The slope is $1.50 and it represents the cost per movie. That is it. Are there any questions from anything on here? Fantastic. Grab your computers.